Welcome back to the ICND 1 series, and in this video we'll be continuing off from the previous video looking at layer 2 protocols, and more specifically we'll be looking at the LLDP protocol in this video. So LLDP stands for Link Layer Discovery Protocol, and it works exactly like CDP, but it works for any vendor. So LLDP is used in a mixed vendor environment. Unlike CDP, LLDP allows a network device to advertise information about itself to other neighboring devices, and this can be used to help build a network diagram. So with LLDP, it allows for a mixed vendor environment. With CDP, CDP only works with Cisco devices, so in this case, all the devices in a network would have to be Cisco in order for CDP to work properly. Imagine these are switches, this is an IP phone, this is a router. In this case, these devices would all have to be Cisco devices. With LLDP, this could be a Cisco device, this could be a HP device, this could be a HP phone, this could be a Juniper router. And LLDP, because it is vendor neutral, it allows these devices to all share information about each other, and allows the Cisco device to learn about the devices that connect to it, even if they are non-Cisco devices, which is an advantage of LLDP. Unlike CDP, LLDP supports what's known as TLV attributes to send and receive data with the neighboring device. TLV attributes just describe information about the device itself. So in this case, when this Cisco device is sending information about itself to this HP router, it will list information about itself in TLV attributes. So its device name, its IP address, its interface number, its interface description, all that's listed as TLV attributes with LLDP. LLDP also supports an extension called LLDP-MED, and this extension is used to provide support for voice over IP applications. More specifically, LLDP-MED is used when we have a scenario like this: a switch and an IP phone. LLDP-MED is used so that the IP phone can send information about itself to the switch, and this is a very specific case where LLDP-MED is used. Now, LLDP sends packets to the multicast MAC address of 0180C20000E. The reason why LLDP uses multicast addresses is because it means that it can generate less packets and sends packets to multiple devices. So instead of having to send a unicast packet to each and every device, that means that the switch or the device would have to spend time creating the packet for each device, for each neighboring device. It can create one packet and send that packet to many devices. And because this packet is sent to a multicast address, it means that devices that don't support LLDP, that don't listen on this multicast MAC address, they will not process that packet. So these are the additional TLVs used for LLDP-MED. The capabilities TLV, network policy TLV, power over Ethernet TLV, the inventory management TLV, and the location information TLV. At the CCNA level, it's not really necessary to know what these TLVs do. If you want, you can view what they do and the description of these TLVs on the Cisco official website, on the Cisco official documentation for LLDP. Just important to know that LLDP supports an extension called LLDP-MED, and that's used between the switches and IP phones. It allows the IP phone to send information about itself via LLDP to the switch. CDP supports the additional type length value fields without any extension. So understanding LLDP. LLDP updates are sent every 30 seconds, which is half the time that CDP updates are sent. So we know that CDP updates are sent every 60 seconds. LLDP will send updates every 30 seconds. So imagine we have this scenario, these two switches, switch 1 and switch 2. Switch 2 will send information about itself every 30 seconds to switch 1. Switch 1 will store that information, what's called cache, store that information in its LLDP table. And that information is stored for the whole timer, which is 120 seconds. The way it works, when switch 2 sends information about itself to switch 1 in an LLDP packet, switch 1 will store that in its LLDP table for 120 seconds. If it doesn't receive another LLDP packet from switch 2, it's going to forget the information and remove from its table. When it does receive an LLDP packet, it's going to refresh the timer. So normally what you would see is that with the show LLDP enables come on, the timer will go all the way down to 90 and it will be refreshed back to 120 because it's receiving packets from its neighboring devices every 30 seconds. The LLDP also supports what's called a reinitialization timer. And then this timer is just how long we have to wait before we can re-enable LLDP on a port. So in this case, if we have LLDP running and we disable it on a port, before we can re-enable it again, we would have to wait by default 2 seconds. Now this is the format of an LLDP packet. The chassis TLV, port ID TLV, and TTL TLV are all mandatory TLVs. So in every LLDP packet, we will see the 3 TLVs. Now we can have optional TLVs which describe additional information about our device, and again we can configure which TLVs we want to support, or we can leave it to a default. So optional TLVs could be the IP address, the native VLAN management addresses, is kind of the same things as the CDP packet. So configuring LLDP. By default, LLDP is not enabled on Cisco devices. By default, CDP is. If we want to enable LLDP, we would have to disable CDP and enable LLDP globally by using the LLDP run command. We can also enable LLDP on an interface, on specific interfaces, but that is different to how we enable CDP. You remember that with CDP, we can just use the CDP enable command to enable CDP on the interface. With LLDP, we have to enable the interface and for receiving LLDP packets and transmitting LLDP packets. So in this case, the LLDP receive command tells the switch that it can support receiving LLDP packets on the interface, and the LLDP transmit command tells the device that it can send LLDP packets out that interface. We can also define how often these updates are sent with the LLDP timer seconds command, and we can define the hold time, which defines how long information received from neighbors is stored in the table with the LLDP hold time command. And we can also define the reinitialization timer with the LLDP reinit seconds command. And this in brackets is just the value that we would put. So this is the actual command in this case. This would be the actual command. This is the value. So it could be 20 seconds, 40 seconds, 50 seconds, depending on how often we want updates to be sent and how long we want to store that info for. And we can also define the type, length, value attributes that a device can send and receive by using the LLDP TLV -select command, and we can define the MED type, length, value attributes a device can send and receive by using the LLDP-MED TLV select command. So as you can see, LLDP is much more customizable than CDP. We can, with LLDP, we can advertise much more or much less information to our neighboring devices than with CDP. With CDP, we're kind of limited to what we can advertise or what we cannot advertise. Whereas LLDP is much more customizable, that we can advertise a whole range of things, and we can limit and we can severely limit what we want to advertise to our neighboring devices, which is one of the reasons why some companies use LLDP. And we can verify LLDP by using the same commands as with CDP, apart from we just replace the CDP part with LLDP. So as an example, show LLDP shows the same things as show CDP. It shows how many packets have been sent or received, and just global and just general information about LLDP. Show LLDP traffic shows LLDP traffic. Show LLDP neighbor shows all the neighbors that the device had learnt about via LLDP, and show LLDP entry name or star shows detailed information about those LLDP neighbors. Here we can see command output from a LLDP command. So as you can see, show LLDP neighbor detail shows detailed information about this neighbor, shows the chassis ID of the neighbor, the port ID, the port description, the system name, shows system description, time remaining, system capabilities, enabled capabilities, we've got management address, we've got physical media capabilities, so what interfaces support. So as you can see, we're actually getting a lot more in information than with CDP. If you think about it, the information with CDP is quite basic, but CDP does have other advantages as well, such as it can be used to detect errors, things like native VLAN mismatches and duplex mismatches. So we've reached the end of this video, and we've reached the end of this section covering layer 2 protocols. Just as a quick recap, we've looked over CDP and LLDP. CDP stands for Cisco Discovery Protocol. It's the layer 2 protocol used for discovering neighbors enabled by default on Cisco devices. It supports it's a lot less customizable than LLDP, but it supports better error reporting management features, However, LLDP can be used in a mixed vendor environment, and both essentially do the same thing. They both allow a Cisco device to advertise information about software neighboring devices. With LLDP, those could be any vendors. With CDP, they have to be other Cisco devices. I hope this has been informative for you, and I would like to thank you for viewing.